Good morning, good afternoon, good evening. I'm here to talk to you about WebScale database infrastructure operations Galera Cluster 4. I'm Colin Charles from Galera Cluster. So let's get into it. First, who are Codership? Codership is an Galera Cluster company was established in 2007. Their founders, all of whom are engineers. Everyone's fairly technical, from Seppo the CMO, the CT, and Alex the architect. Follows the services business model of open source software, for exploring other options besides just source. And there are thousands of various industries, being, betting, gambling, telco, SaaS, IaaS. It's basically very widely software, well tested kinds of applications. And if your app cannot tolerate downtime, data loss, lost transaction, Galera Cluster is the right solution for. And of course, it is extreme to use and get set up. So the biggest gain here is setting up Galera. It's very easy. Tuning it for performance is a little hard. So when it comes to web scale operations, we should ask ourselves, what is high availability and what are we trying to achieve from availability? We always think of it from a performance and scalability standpoint, in where we measure throughput in transactions per second. We also measure latency in response time, which we measure in percentiles, which you'll find out a little bit more in the next slide. Let's talk about durability. Because the E in ACID is basically durable. You don't want to lose commit data. We can do this in multiple ways. Either we have replicas, shots, spam recovery, or backups. From the Galera standpoint, everything is sort of a replica. It's an equal replica. Also, we think about monitoring. We want to make sure that during string we have good monitoring, we have recovery, failover, so we don't have time that service is down. And again, with Galera, these no tend to be really equal. Then we also have ability to do replication. Replication is basically just ensuring that there is redundancy in your set. So, what is uptime? Many people like to say we have several nines worth of uptime, but if you have 5 nines worth of uptime, it means that you have a max downtime of 5.25 minutes a year. So it's very fashionable to say that that is what you want, but that are you willing to invest in the infrastructure to ensure you get that? So with something like Galera, you have multiple copies of your data. There's a good chance that you could probably have several nines worth of uptime. So there are replication available in the MariaDB. There is application where insert into a primary, and it's very fast. There are no guarantees that any of these will receive such transactions. You may also have secondary line, and if you were going to do any kind of, if the primary dies, there's no way for them to take over unless you have automatic failover frameworks, a secondary, the new one, and you want to ensure that it's got the options, it has transactions. If there's a secondary chance that you may also lose transactions, it's just far from optimal. It's very fast. Everyone uses. There's also semi-synchronous replica. Insert into then at least one secondary will receive set. So even if the primary all is obviously a little slower because to one other, but that's okay because you're getting mobility and you're ensuring nothing wrong. And this is WebScale companies also tend to run. So the likes of or Google, they all semi-synchronous. Then there's also virtually synchronous cluster. Where you insert with just to one node, but when it actually writes to all the, you don't actually need any kind of automatic fail like you do for the semi-synchronous variant. Because the idea of failover is that you can actually have to deal with already built in. So Galera, following the Galera virtually synchronous model, you can actually write to node 1, node 2, and it will all be equivalent. So you'll find that, as I say, so does multi-mother solve? So, we want to write queries that are not affected by limit with elevated latency links. We really never want writes on them to be visible later on secondary standbys. Replication delays, definitely good for you. Want clients at the secondary site lose access if the wide area network link is disrupted. We use the term wide area network changeably with cloud because cloud is basically a wide area network. We also don't want split, so two active but separate masters. We don't want to manage shooting the other node ourselves. And we really want the node divergence automatically moving once that turns with no manual repair synchronization when you have a multi-memory cluster. And this and more can be provided to you, Galera. So let's look at multi-master as another tool. It solves many problems but requires additional design constraints, some of which I'll talk about towards the end. Deploy it when it solves your problem. Definitely do requirements analysis, understand that are available to you. Galera provides for shared nothing storage, so you don't have to use a SAN. Consistency and isolation ensures that your asset is preserved. No geographic limitations. You can run in multiple data centers in, say, Singapore, you know, London and San Francisco. Data conflicts are prevented. You never have conflicting data sets. You have synchronous commits of all nodes, or as we like to say, virtually synchronous commits, and it's generally transparent to the application overall. So what is Galera Replication? It's a generic replication plugin for database servers. It uses the Replication API to interact with the database management system via the wsrep API project, fully open source on GitHub. And wsrep basically stands for write set replication. The database and Galera plugin must have the same wsrep API version. And I'd be remiss to mention that there's something similar, obviously, called the MySQL group replication, and the form of that is MariaDB cluster as well. So, there are many ways you can have replication API. So, when it comes to multi or multi-master replication, it basically looks like one very large with multiple entry points. Transactions are processed locally until commit time, then replicate across nodes of the entire cluster. It is virtually synchronous, such that each is immediately replicated on all nodes at commit. You don't have any stale secondaries. All nodes are equal. It is obviously multi-primary. You can read from any or write node, and there's automatic transaction detection. There's lots of replication going on, so tie data set on all nodes. New nodes can join. It is, of course, InnoDB when it comes to a Galera. You can't use other fancy storage engines. Data is obviously protected, so you avoid stale data, and it also prevents modifications to data. There's obviously full wide area network support, so node can be on a continent. It can also be encrypted, and optimized communications with least latency can be described as virtually synchronous, as I was mentioning first. It uses quorum-based failure handling, again, why you have a minimum of nodes as opposed to having two nodes. So if it goes away, thirds still makes a quorum, keep the cluster going. Uses the concurrency control to ensure that when you write to say node applies to node 2 and 3, before it says okay, client. And all this is basically a core feature of the product by design, because it's not something that has been added on, party software either. You don't need to do any automated levels via it because basically just works. It's meant to work. It's totally optimized for the cloud. So the network protocol as packets are only exchanged over the wide area network at transaction commit time. And topology aware applications, you can also segment stuff. So each transaction is sent to the data center only once. Also, if they're unreliable nodes, so flappy network problems or nodes keep on getting disconnected, eviction will happen if this happens, and it will be able to run without manual intervention. And there's no split brain problems when you configure Galera cluster properly. And of course, traffic encryption is key in the cloud, so SSL is available. Also, of course, the reason why we're having this talk is because we want to talk about the new features that are available and the highlights around it. So, we have obviously got streaming replication. We've improved foreign key support. We've built in even more network resiliency. We've got GTID compatibilities with MariaDB, group commit support in MySQL 8, and also some MariaDB Enterprise only features that I think kind of exciting and or interesting to a lot of you. So, streaming replication. It's based for supporting huge transactions because all nodes currently process write sets in a single memory resident buffer. So in Galera 3, transaction process on the master node until commit time. For large transactions, the write sets will be too large and hard to process. So we introduced wsrep max ws size to prevent very large transactions. And when I say large transactions, I'm referring to anything larger than 2 gigabytes in size. Then we introduced something called streaming replication. So you can actually now run transactions of unlimited size in a cluster, and of course you can still reject large transactions. Now, why would you like to run a transaction that is larger than 2 gigabytes in size to begin with? Maybe you have long-running transactions. Maybe you want to do a load data in file that is very large. So basically, you can actually set wsrep max ws rows or wsrep max ws size to limit the transaction rows to 128 kilobytes and the transaction size up to 1 gigabyte or 2 gigabytes. And we have a fairly good guide on how to handle large actions, including the ability for you to use archive. We can also definitely do streaming replication because now what we do is we replicate transactions gradually in small fragments while the transaction itself is processing. So before an actual commit happens, Galera is actually replicating small chunks or fragments to other nodes. So you can set the size threshold for said fragment at runtime. It's dynamic, and replicated fragments are then applied in slave threads, preserving the transaction state in all cluster nodes. Basically, the fragment locks in all nodes and cannot be conflicted with later. Streaming replication allows nodes to process write sets greater than 2 gigabytes in size as well. Now, to configure streaming replication, all you need to do is play with these session variables, wsrep transaction fragment unit. So you can just have unit metrics for fragmenting options, again in bytes, rows, and statements, and then wsrep transaction fragment size, which is got threshold units. When the fragments will be replicated, 0 basically means no streaming. Now, initially, there will be a lot more logging and elevated replication overhead, so streaming replication will cause degraded transaction throughput compared to regular non-streaming replication. The best use case today is to definitely cut large actions down into size. You can set the fragment size to around 1,000 rows. This is something we've done multiple times. I think this is about a good example. Of course, applications can also get streaming replication on and off on a need-by-need basis, but you need to change the application. But as I said, this is all dynamic, so it can happen on a per transaction basis. We also added a bunch of new metadata, wsrep tables in the MySQL database. So the three new Galera Cluster system tables are wsrep cluster, wsrep cluster members, and wsrep streaming log. Yeah. And this is present in, of course, MySQL and MariaDB. I will make clear when something is only present in one or the other. So what do you have in wsrep cluster? It basically shows the current view of the cluster, some identity information, as well as cluster capabilities. Cluster UUID is the unique user identifier of the cluster. View ID corresponds to the status value of the wsrep cluster conf ID. The number of cluster configuration changes which have occurred in the cluster. The view sequence number, on the other hand, corresponds to the Galera sequence number associated with the cluster view. The protocol version is the same value as contained in wsrep protocol version variable. It's the protocol version of the MySQL wsrep or the MariaDB wsrep patch. And lastly, the capabilities column contains the capabilities bitmask provided by the Galera library. It's metadata that will be needed to recover node state during crash recovery. wsrep cluster members is fairly easy. The results of this example, you can see that this cluster is composed of 3 nodes. All the node UUIDs are unique for each node. And then you can also notice that the cluster UUID is the same for all 3 and corresponds to the related value found in wsrep cluster table, as I showed in the example earlier, the previous slide. Each node obviously has a unique name, so Galera 1, Galera 2, Galera 3, and they were named in the configuration file using the wsrep node name parameter. The incoming node address is set to auto for all these nodes, but they can also be set to specific nodes with the wsrep node address or the bind address parameter in each node's configuration file. So this is the MyCNF. So wsrep streaming log, well worth noting, because it contains the metadata and row events for ongoing streaming transactions. Typically, you will not see any results because it only contains entries for transactions which have streaming replication enabled. We also have introduced wsrep functions, stuff you can build into your application. They are wsrep last seen GTID, which returns the global transaction ID for the last written transaction observed by the client. There's also wsrep last written GTID, which returns the GTID of the last write transaction made by the client. And there's also wsrep sync wait up to GTID, which blocks the client until the node applies and commits the given transaction. So this all requires application changes, but it's also something you can do and utilize to bake in your Galera cluster usage. Also, we have lots of improved foreign key support. So there's write set certification rules optimized now to handle foreign keys. So if you have previously seen false conflicts in certification in your logs, this will now disappear or there will be a tremendous reduction in it. So added bonus. Now, what happens if you have poor network connections? Galera cluster is definitely now a lot more resilient when it comes to handling poor network connections. Basically, there's a feature we call cluster voting, and it started live in MariaDB Jira under MDev 17048. A new feature implemented by XC, and it's a protocol for nodes to decide how the cluster will react to problems in replication. When one or several nodes have an issue to apply an incoming transaction, a suspected inconsistency, this new feature will help. So in a 5-node cluster, if 2 nodes fail to apply the transaction, they get removed, and a DBA can go and fix what went wrong so that the nodes rejoin the cluster. So we're now able to handle irrecoverable errors due to poor network connections a lot better than before. Cluster nodes will leave the cluster as gracefully as possible if it can't recover from the errors, but it will never ever sacrifice data consistency. This is amazing for geo-distributed Galera clusters. We also have group comment. There is support for group commit natively with MySQL 8's binary log. Now, this is obviously fairly important because you want to, because many times people actually also have the binary log turned on for quick recovery sometimes, or even if they want to attach asynchronous secondaries. Their commit time concurrency controls have been reworked such that the commit monitor is released as soon as the commit has been queued for a group commit. So transactions are now committed in groups while still respecting the sequential commit order. So this is like a huge performance boost, I would say, if you're using MySQL 8. Then there's also GTID compatibility inside of MariaDB 10.5. So Galera Cluster, of course, can also operate as a secondary to a MariaDB primary server, and GTID coming from the MariaDB primary is preserved in the Galera cluster because now you'll find that the same GTIDs are available in the binary log file. And the reason behind all of this is, Galera stores GTIDs, global transaction IDs, as UID sequence number, whereas MariaDB stores as domain ID, node ID, sequence number. And now Galera cluster uses the same domain and node ID, and the software will only store and show the MariaDB format GTID. We've also done some work with MariaDB Enterprise. And the non-blocking DDL is kind of a exciting thing, I would say, because it's similar to total order isolation, which you can use, total order isolation and the RSU methods that are always available. But alter table, create index, drop index, and optimize table are used now for much more efficient locking. It's the NBO option. So TOI is the default. In this mode, DDL statements only need to be executed on a single cluster, and the cluster node will replicate to all cluster nodes. All the cluster nodes will then execute the DDL statement at the same location in the replication stream to ensure consistency. Method is very safe, but it can result in more locking than other modes. RSU, on the other hand, has the DDL statement executing on each cluster node separately. And if the DDL statement causes the table to change in a way that is not backwards compatible for replication purposes, then the mode can lead to replication errors. So therefore, it is only recommended to use this mode if the specific schema change is backward compatible for replication purposes, or if write activity for the specific table has been stopped. And then NBO is where the DDL statement only needs to be executed on a single cluster node, and the cluster will replicate it to all other cluster nodes. All cluster nodes will execute the DDL statement at the same location in the replication stream to ensure consistency. So in that way, it is similar to TOI, but this mode uses a lot more efficient locking for the same operations that the TOI does. And inside of MariaDB, again, Enterprise, we have the ability now for you to encrypt the gcache since MariaDB Enterprise 10.4 onwards. So when you turn on encrypt bin log equals on, not just the IB data, reader log, binary log are encrypted, but also the gcache is encrypted. Now we also have black box, which is a feature implemented by Pekka, and it's only available in MariaDB Enterprise Server. It allows you to store debug messages in the main memory, the SHM ring buffer. So it helps with troubleshooting a crash server, or even when you're doing cluster testing. We have Galera 4 and MySQL 8 since May 2020. Basically since 8.0.19, comes with wsrep API 26 and the Galera 4.5 library. wsrep is integrated into the release of the MySQL 8 that is shipped, and you can of course download it today. We have of course updated it since then, but since May 2020, you've been able to actually use Galera for MySQL 8. There are of course a few application thoughts that are worth taking a look. And one of them is you have to know that all table primary key. It's extremely important when it comes to your cluster. You really don't want to have any table with primary key inside of a Galera cluster. You want to make sure you're only using DB as a storage engine. Make not using any XA transactions because Galera doesn't support it. You definitely cannot use log tables or unlock tables because again, Galera support that because you don't want to do this in cluster. Now, when it comes to something called high concurrency hot rows, a lot of people don't set the retry auto commit to have a number. So probably set the retry auto commit to maybe say 5. So basically high concurrency in the database is where you have a lot of update same exact row. And you need to use something like the retry auto to a higher value to ensure that the app knows to expect a delay. Note that two transactions writing the same and committing to separate nodes means only one can successfully commit because it's optimistic concurrency control, so you'll get a deadlock and you need to read transaction. Also, if you have applications that control MariaDB users or MySQL, there's DDL statements into that are replicated at statement levels. You have to do things like create user rather than directly to the MySQL user table. And of course, schema upgrades like schema changes, either a rolling schema upgrade or load isolation as a cluster, definitely requires some planning, even the non-blocking option that is available inside Enterprise. Upgrades are fully supported, so you can actually migrate an wsrep 25 MySQL 573 cluster nodes, isolate node, making one read only. You have a 2-node cluster for read-write, down the server, upgrading to MySQL 8. Not without the wsrep provider, run MySQL upgrade. This is extremely important when you're doing major version upgrades, running MySQL upgrade. On the server, restarting with the provider, and then allowing read-only access. And then you can upload 2, then you shut down node 1, allow read-write access, then do node 1 as an upgrade complete, and then repeat again for node 3. And this is how you are having a node cluster. It is a bit tedious, there's no automation around this, but it ensures that you can do upgrades without having to do dump restore or having downtime. Monitoring is done fairly simply via things like show global status. Of course, remember that if you do flush status, it resets the status log, so maybe don't do that too often. Galera reports everything via the MySQL or MariaDB server error log. Monitor each node separately for maximum effect. Monitor the health of the network, round trip times, bandwidth, utilization, network links between any 2 segments, or 3 segments if you have 3 data centers. One way to try MariaDB Enterprise is to get on the free MariaDB SkySQL train. That's $500 credit. You can play around with 10.5 if you like. What's next? XA transaction support is coming. It's a feature implemented by 2 of our developers, and we wanted here for Galera Cluster to operate as a resource manager in an XA infrastructure. There is a transaction coordinator where Galera Cluster can operate as an XA resource manager, so the Galera Cluster should be able to prepare or roll back or commit a transaction. XA transactions are supported thanks to the implementation of streaming replication, which is a foundation for it. The work has been ready since MariaDB 10.4, was not accepted in the main tree, and likely targeted again for 10.5, but missed the train. So basically, it will definitely be in MariaDB server 10.6. There is also, on top of that, we can build the idea of a sharding cluster via Spider. So MariaDB 10.6 includes XA transaction support testing and documentation to make Spider cluster work as well. So Spider is a storage engine that is part of MariaDB that also depends on XA. And then this helps MariaDB become a sharding cluster. So you have extreme write scalability that could come from such a setup. Now, the disadvantage of sharding cluster being built via Spider is Spider does not work with MySQL any longer. So this will be another MariaDB community and enterprise feature that will be currently basically missing from the MySQL world. And we will work, and based on needs, we will definitely want to work on sharding cluster for MySQL as well. There's also dynamic SSL TLS implementation. We want to make it much easier for the end user to turn on SSL or TLS because most of our Galera cluster users are running in the cloud. And then of course we'll do further optimizations for streaming replication because that's just something we have to do to make things better, faster, and let people use it. So quick comparisons with other variants of Galera 4. So MariaDB server has had 2 releases now, 10.4 and 10.5. With Galera 4 since 2019 and 2020. Percona XDB cluster actually did make a release of Galera 4 based on the MariaDB codebase at the end of April 2020. And Codership, us, we made Galera 4 with MySQL 8 May 2020, so about a month after Percona. Of course, we have to do some quick comparisons with other variants naturally. So MariaDB Server 10.4 includes use of backup locks, which you can use with Maria Backup, so use SSD for lightweight locks. Percona XDB Cluster 8, of course, includes all the features you're familiar with Percona Server, but it also comes in addition with things like Proxy SQL, a Kubernetes operator, encryption plugin thanks to Vault, PXC encrypt cluster traffic is enabled by default. So that's something that you also see that we were thinking about wanting to do, but there, unauthorized SSDs will then occur, and MySQL upgrade because data dictionary is versioned in addition to MySQL. Things like gcache recovery is turned on by default, including PC recovery. These are all configuration file options just made to make it easier. And of course, PXC includes extra backup ship by default. But overall, in summary, the developers of Galera Cluster are Codership. The most developers of Galera Cluster are at Codership. And of course, who knows the code better than anyone else? It's basically again Codership. So who decides the roadmap of Galera Cluster? It's back again to Codership. And our main partner with MariaDB Corporation, we also listen very closely to the community. We've also recently dabbled with doing a GUI tool, a GUI deployment tool, which you can find at galeracluster.com. So it's called Galera Manager. We highly recommend you take a gander at it. I could obviously do a demo if that's required. But yeah, if you have any questions, please do shoot me an email at colin.charles@galeracluster.com, or we'll hear you on Slack. Thank you very much.
Thank you, Colin Charles, for registering for MinervaDB Athena 2020 and speaking in the event. Great, man. Happy to see you in Athena 2020. Welcome.
Thank you very much for the invite, Shiv. It's great to be here.
All right. I tell you, when we were almost towards the closure of the talk, choosing the talk for the event, most of the committee members came front are like, hey, something, Shiv, there are interesting talks happening on MySQL performances. MariaDB talks are happening. There are PostgreSQL talks, and there are also Linux SRE talks. Can we miss Galera Cluster talks? We can't. The reason because it's like, one, when you're talking about data reliability, the first thing on comes on both on MySQL and MariaDB is like, hey, how we can evaluate Galera Cluster if you're building a zero data loss replication infrastructure. And so that, hey, because I didn't see any submissions, so I thought I'd directly reach your team, and you guys have been so quick and fast, so thank you for that. I was going through your talk. It is like Galera Cluster 4. We'd like to know about, we'll be very curious about what are the most compelling reasons for a production infrastructure team to migrate to Galera Cluster 4. What do you see is looking great or on the reliability perspective on Galera Cluster 4 compared to the previous releases? I'd like to know about
Yeah. So again, thank you very much for reaching out. I guess very importantly, with regards to Galera Cluster 4, the major feature we brought out was streaming replication. And that basically means that you can now have very large transactions greater than 2 gigabytes in size be replicated across Galera nodes in chunks. And it could be chunked up via rows, which you can configure at runtime. And that's not the only important feature that we came up with that would benefit lots of people in terms of an upgrade. We also have, writes and replication functions that you could actually input into your application to wait for cluster status. We've also added a new monitoring available inside of the MySQL tables. We've expanded such that if you're going to have a flappy network or need more reliability in the network, the algorithms have been hardened up tremendously. I think the biggest gain you get from Galera 4 is that it's actually comes with MySQL 8 as opposed to MySQL 5.7 and Galera 3. And this is also true even in the Pacona XGB cluster 8 space, which also brings you Galera 4. And for a while, actually, to be fair, MariaDB 10.4 has already had Galera 4. So MariaDB 10.4 came out middle of last year. 10.5 is out, middle of this year, and it's also available in the SkySQL cloud. So while MariaDB gets Galera 4 first, and if you end up using the SkySQL cloud, you'll get to even do things like get full-on encryption. So the gcache is encrypted as well, as opposed to just the all the other tables and files. So we definitely see a lot of benefit for one to upgrade to Galera 4. And I think the biggest reason is also the fact that you're getting MySQL 8. So, MySQL 5.5 is clearly getting old, if not deprecated. And then there's 5.6, which is also fairly old. So, having a 5.7 for a very long time, 8.0 is a clear benefit. So you're getting all the benefits of 8, JSON. The fact that it's also integrated with the MySQL group commits, so you're getting more and better integration with InnoDB. You're getting a lot of reasonably good features with 8. So I think upgrading is not just to get new features, but also to get stability, to also get performance improvements, and to be more reliable. And obviously, you get more monitoring options as well.
Mm-hmm. Oh yes, like when you said about the monitoring options, I was about to ask you that the as you become more and more feature rich, when you talk to me about the streaming replication, that means like we are talking about the I don't say it as a compliant, but then always it is about the if I'm a database reliability engineer who is building a zero data loss database infrastructure on a synchronous replication using Galera cluster, I will always have a concern about, look, there is going to be latency when there is going to be a distance, the physical distance between my server goes high. Now, when you tell to me that, hey, something, we are going to ship streaming replication that's going to be more high performant replication compared to the previous replication what Galera cluster was talking about. Now, as you rightly said, one, it is a MySQL 8, like write set replication API infrastructure from Galera cluster. Two is about the streaming replication integrated to that. Do you have any good news for somebody who has? I'm not talking about multi-city Galera cluster, but then about multi-DC with a significant distance in the same city. Like so. Do you see?
Yeah. So with a greater latency is basically what you're going for. And yeah, Galera I mean, even in the later releases of 3 had a more optimized network protocol for far latencies, as well as nodes that were a bit flappy. So even if you had multiple data centers, it didn't write to every node, for example, it was writing to elected nodes. Now, obviously the algorithms have improved a little bit, and we expect that the next release will have even more improvements. Streaming replication, I think, was a very good base for what is coming next. So obviously, if you use streaming replication, we'll also tell you that there will be obviously some kind of performance hit compared to regular replication because it's now chunking everything up. But at the same time, this is the very important base for what comes next. And what comes next is also obviously things like support for XA and also obviously improved performance. So I'd say migrating to 4 and using my MySQL 8 is a good stepping stone to where you go next. And obviously we support upgrades going up from say 3 to 4 and 4 to what comes next. But we don't go backwards. So yeah, definitely you'll see improvements even when it is more latent, so to speak.
Thank you. So this is something I was talking this on one of the user conferences hosted in Jakarta in Indonesia 2 months back. This is again a virtual conference, right? The concern was like it was a concern from the conflict detection in MariaDB when you have a multi-write infrastructure. Though MariaDB it was a MariaDB plus Galera cluster. So though it is like internally from MariaDB, they always recommend like multi-write is something which you have to be cautious about. They don't discourage that, but then they say like you should be cautious about. Whereas Galera cluster say that it's okay you do multi-write provided you know how multi-write works. It's fair for you. But when I was going through the Galera cluster for release notes, I could read somewhere that there is more responsive conflict detection is coming up in Galera cluster 4. Do you want to share with us some high-level story of that? That'll be great.
Yeah, we definitely have a lot more responsive conflict detection. We also, remove things like erroneous foreign key conflicts that used to appear in your logs. So sometimes they were just appearing in your error logs, but they weren't actually really a problem. So we've actually fixed some of that stuff. So if you're using foreign keys and you're finding lots of problems, you'd see that. And also conflict detection algorithmically has improved. Internally, there's been some changes to the way these structures are handled. And yeah, of course, yes, multi-writes are obviously supported if you know what you're doing. But at the same time, if you have proxy in front, be it MaxScale or Proxy SQL or HA Proxy, one of these could totally help you if you're starting to see a lot of conflicting issues. Of course, the other very basic one is the write set replication retry auto comment, which many people don't set. So I guess the thing about Galera is it's a bit of tuning. Setting it up is really easy. It takes like 5 minutes to set up a 3-node Galera cluster. but
Mm-hmm.
making it tuned for actually running takes a little bit more effort. I think that's what a lot of people tend to miss out on.
Mm-hmm. Right. So that takes me to the last and the final question of this conversation. Like, uh, as an evangelist and strong community advocate of Galera Cluster, what could be the top three recommendation you say when somebody is setting up Galera Cluster for scale? I'm just not looking at from a performance perspective, but then from a
Mhm.
scale perspective. You know, like when I have more number of nodes, I will not be disappointed on deeper latency issues. So do you have something like three things if I do that right at a scale, Galera Cluster will do good for you?
Yeah, I think the first thing, even though won't be to get to scale, but to get you started is to actually turn on logging. Like make sure you have verbose logging turned on.
Mm-hmm.
It's off by default. Then the next thing to do is obviously configure your gcache page size relatively well, because
Mm-hmm.
I've seen so many installations where there is no configuration and the default configuration is 128 megabytes. So pretty much every time a node goes away, you end up having a full-on state snapshot transfer at SST, right? So and you really want IST, which is an incremental snapshot transfer. And then so that's basically two things. And then the other one is the easiest thing is to make sure you've got retry auto commit turned on. And I guess the other added bonus is if you really are wanting to scale, you got to make sure you have access to also potentially change the application to ensure you're not hitting things like hot rows, for example. I think that's very common. But we also see like well, now we've gone way past three, but we also see very commonly like people say, hey, we've got all these DB tables without primary keys, and you know Galera, it works, right, until it stops working when you need to run a delete, for example, or things are out of order. So there are obviously some limitations that we already list. I mean, not we only, but everyone lists, and Percona has a strict mode for this. MariaDB has a forced DB primary key mode for this. It's just that we just need to turn on these options to make it even stricter, to make sure you enjoy using and scaling with Galera Cluster, so
Thank
you
you.
don't end up making mistakes. Yeah.
I mean, this I tell you, how coincident is this? So I was talking to one of our core committee members, right? Do you end up in overlogging Galera for more data, and that becomes a bottleneck of extra writes happening there, right? And when you say this, right, like uh, when you know what you are doing, or when you are configuring Galera purely for reliability, right?
Mhm.
Then you are discounting the fact that like one, the conflict detection is taken care. Two is that you will not have a conflicting write which is going to happen on the node, and you end up in shooting both the nodes. The third one is
Mhm.
about how do you tune Galera within Galera, not from Percona or from MariaDB for the
Mhm.
performance. Within Galera, when you tune, you benefit more. Interesting, man.
Yeah, definitely tune Galera. Like, don't only tune your server. Most people just have a very basic
Very true.
Galera.cnf, or yeah, it's just here's three nodes. Go get started, and Galera will get started. That's a thing.
Yeah, then Galera is very tolerant. So this is something which is my personal observation. Galera is highly tolerant. That said, if you don't handle Galera properly, then Galera knows how to keep you safe. So I
Yeah.
don't
So
call it that. Yeah,
it's
yeah.
a trade-off between ease of use, which is the ease of installation, and also the ease of actually getting going. And yeah, I think documentation is something we can all improve on. So it's there's a hodgepodge of documentation between Galera and MariaDB as well as Percona,
Mm,
and even I regularly find some deprecated variable that is in say one variant of the documentation. But that's, I guess, the beauty of uh, the community adopting the solution, is that everyone doesn't keep necessarily track, and then we can all just email each other and say, please fix this documentation error.
this is my personal observation. Now that we see Colin in a Galera cluster infrastructure, right? I mean, ecosystem, not infrastructure, ecosystem, right? We are seeing you in We've seen you in a MySQL ABA big time. You've seen you very active in MariaDB. You've seen you very active in Percona, right? Wherever you have your presence is there, there will always there'll be a greater level of access to the clarity, right? I don't call any documentation perfect documentation, but the clarity gets wider actually. I'm sure not just me. There'll be a lot of people looking forward to that, man. Colin is there. No, we get more data out from the Galera cluster. Happy to have you there.
Thank you very much for the nice words, Shiv.
All right. These are all something from me in this conference, Colin. Thanks again from MinervaDB Athena conference committee for coming on a very quick short notice and submitting your talk and giving us more insights on making Galera cluster infrastructure operations more successful for respective business. Looking forward to seeing you soon and wishing you a very happy Merry Christmas in advance and a great 2021. More happy, more healthy, where we all can keep moving around.
Likewise, Shiv. A very early Christmas, good New Year. It's going to be another great year, I'm sure, for all of us in the open source database ecosystem. Thank you.
Thank you so much, Colin.